Moving on, chapter 22 continued. We're gonna take a look at how we can make a nitro group into an amine. Nitrobenzene into a much more popular aniline. Yeah. Amines are very important, and it's important to remember all the ways to make them, especially since chapter 23 is called amine. So yeah, this is a beautiful little segue into our next chapter. Nobody knows how to put an NH2 group directly on benzene. If so, they would have been a very, very wealthy person. Okay, we don't know how. You've got to first put a nitro group on benzene, which we're doing right here. And that we've done a couple times today. And you need the combination of nitric acid, sulfuric acid. Generally requires a little heat. I will not grade heat on this one. It's a slow reaction. To get nitric acid to lose water is kind of slow. And the next reaction, there's a reason why there's 4 ways here. There's really probably in the literature close to 100 ways. It's not an easy reaction to do, and you generally won't be trying one and saying, yeah, it works. You'll be doing many to get it to work because you need this amine, and you'll pick the one that works well, okay? And you're responsible for learning 4 out of 100 or more. I don't know. And one way is the obvious one. H2, PT. That's one way to do it. It probably won't work. So the great thing about a lecture course is you just say, that's the one that works. And there it is. Or you could use our standard or our fallback reduction. This is the most versatile reducing agent we know. Step 2 is always HCl with that one. I do want to caution you though, lithium aluminum hydride reduces many things. We've already seen it react with many things. Do you want a quick summary? We saw it reduce aldehydes and ketones to alcohol. Yes. We saw it reduce carboxylic acids to primary alcohol. Yes. We saw it reduce esters to primary alcohols. Yes. We saw it reduce amides to amines. Wow. We saw it reduce nitriles to primary amines. It reduces a lot of things. Okay. So if you have other things in your molecule, that's probably not the one you want to use. That's all I'm saying, right? Because it'll reduce everything, so almost everything. It doesn't reduce alkenes because alkenes are non-polar. So if you want like a general memory guide for when do you consider using a lithium aluminum hydride reducing agent, it's when you have a polar functional group that needs to be reduced. Polar. There's a couple others you have to know. One's an interesting one where tin metal and HCl are used. I'm going to edit the first one, which really is going to give us 5 choices, but it's really similar. H2 and nickel. That's a different transition catalyst. And another variation on the bottom one is iron in HCl. Iron metal. Yeah. There's really 5 in here. 1, 2, 3, 4. Heck, learn all 5. And it's very important to learn them because the next step looks like it can go do a lot of things for us. After you've made what's in this intermediate box, square box without a telephone pole beside it is an intermediate. And this intermediate stable at temperatures below 5 degrees Celsius. So really zero is below 5, right? So you would keep this surrounded by an ice bath until you were ready to add one of these other chemicals. And what you get is very interesting. You get this species that has your original nitrogen. It has the new nitrogen. And it's called an aryl diazonium ion. And they are stable at temperatures below 5 degrees Celsius. So keep them surrounded by an ice bath. Because if you warm them up in the presence of water, which is already here, correct? Isn't this water? Then you get, now this might be what you want, but if it's not, don't warm it up. RT is such a common short form. It's understood to be room temperature, and you may use it without explaining it. There's only a few short forms you can do that on. You can use RT without explaining what it stands for. And you make a phenol. I don't believe we've learned how to make a phenol until now. I believe this is our first phenol. Okay. Let's just keep going around. The HBF4 is called fluoboric acid. I know, they shortened it. You can also call it fluoroboric acid. It's H plus with BF4 minus as the anion. And it's the one that will put a fluorine there, which we haven't learned how to put on benzene until now. We got a fluorine up there. Every one of these loses, as you might guess, N2 gas. You would see bubbles if you were doing this in the lab. And H3PO2 is hypophosphorus acid. And it actually does something that looks like it would be something you would never want to do. You're back to benzene. My goodness, why would you want to do that? You're fired. If you did all these steps to get back to where you started from, you're fired. Look around in some videos, though. There's at least 2 that show when you would need to use this reaction. And I'll leave it up to you to find them. If you put other groups on benzene as well, and then you get rid of the nitrogen group, and you get an interesting combination of products. That's all 3 meta groups. Watch the videos. Everything I said makes no sense, I know. What happens if you treat a diazonium ion with potassium cyanide in the presence of copper 1 cyanide, room temperature? You get a cyano group. Yeah, there you go. And I don't think we're going to do activity 6 after all. Oh well.